Hi, we're going to walk down the memory lane on today's On .NET show. Come check us out. Welcome to the next On .NET episode. Hi friends, I'm Maoni, the owner of the .NET Core Garbage Collector. With me is a very special guest. He is the external contributor that contributed to the GC space the most during the .NET Core 3.0 timeframe. Today, I'm going to walk down the memory lane with him and tell you some stories of how we made some of the cool new GC features happen for .NET Core 3.0. Let me introduce you to Mukul from the Bing group. Hi, Mukul.
Hey, Maoni. My name is Mukul. I'm an engineering manager on the Bing frontend team. The Bing frontend is responsible for taking in the user query, enriching it with interesting information that's needed for making a desirable search result, and then sending it to the back end, getting the data back out, and sending it to the user as HTML, deserializing it on the way.
Great. So, your team has been using .NET and then .NET Core for years, right? So we've been working together for years. But we really started to collaborate with each other during the Core 3.0 timeframe. And I think that all started toward the end of last year when you came to talk to me about large pages.
Yeah, that's right. We've been doing this, collaborating for so long, but then with large pages is where it became like a really close collaboration. The way it happened was we have this native app, and it's a performance critical app, and so we're profiling it, looking at hardware counter data, and then the DTLB counter, which is a hardware counter, sort of jumped out at us, and we were like, let's investigate this. So DTLB is basically the data TLB misses, which stands for translation look-aside buffer, and that is used for making page accesses faster. So basically, just to give you a bit of introduction, when you're referencing memory, you're referencing virtual addresses, right? And so we have to convert these virtual addresses to physical addresses. And a couple of ways of doing it. You can go through the page table, or hardware provides these caches, translation look-aside buffers, that you can basically have things cache and things become faster.
Right, because the page table walk can be very expensive. With multiple page levels and all that.
Yeah. So we're looking at this counter data, and we said, wouldn't it be interesting to actually improve it? And did a bunch of research, and x86 hardware has multiple page sizes, so you can't just have 4K, but you can also have 2 megs and 1 gig. So we decided we should experiment with changing the page size for this native application, and we did, and we got pretty big improvements. That's when I stopped by your office and was like, hey, it would be really great if we could do it in the GC.
Right. Of course, large pages have been on my mind for years, right? So there are various reasons why we hadn't implemented the support for the NCLR. I would say that the biggest reason was because as GC had to track the modified pages during background GC, right? So we were using, as you know, the CLR, the native platform was Windows for a long time, and the virtual memory manager in Windows provided this feature called the write watch for you to get the pages that were modified. So background GC was using that for tracking the heap modification, right? So we needed to look at the page that was modified and look to see which objects on that page was marked, and we need to remark them.
Right, as the mutator is running.
Exactly, right. So that was a feature that we got, and of course that was on the page level. So you get modified pages, right? And of course the OS had no idea about managed code, like which pages were truly interesting to us, right? So what we got was basically, if you do any kind of modification, you could be doing modification on an integer field, which was actually not interesting to the GC, right? Because we only cared about the modified managed references, but we still got all the modifications, right? So we would reprocess them, and that's how we track the heap modification. And of course, if the page size is too large, we could potentially be doing a lot of wasted work.
A lot more work than you were doing previously.
Exactly, right. So that would be the biggest reason we hadn't implemented the large pages. But as you know, we open sourced, and now Core is running on Linux. And on Linux, there isn't such an equivalent feature, right? There were some things that were kind of like it, but didn't work well enough for us. So then we started implementing our own write watch in the CLR.
For For cross-plat,
Linux,
right.
For cross-plat. It was for Linux at the time we implemented it, right? So we implement this, and of course, come with that, now we're not limited by the OS page size. Because we just implemented this in the write barrier code. When you actually modify a managed reference, you go through the write barrier. Right. And at that moment, we say, like, oh, let's track which unit of memory you're modifying.
Yeah.
Right? So that means we don't have to be limited to the OS page size.
Correct. So basically, even though the write barrier instruction path length increased, there's a trade-off, which is in this case was useful.
Exactly.
You get the same code on Linux, on Windows,
right.
And it allows this feature to be possible.
Right. So of course that means we only tracked pages that we were interested in. So if you were to modify a bunch of like integer fields, it wouldn't be tracked because we don't need it, right? So that means we can decouple the OS page size with the page size that we wanted, or the modification memory unit size that we wanted. So that was nice. So that kind of made supporting large pages a viable thing to do in the CLR, right? But I asked you to hold off because I had another feature that I was working on at the time, which was hard limit, right? So as you know, in 2.2, we had quite a bit of complaints on container support. Yeah, because people started to use core on a lot of things, which included containers.
The small containers getting out of memory exceptions.
Right, and because they use ASP.NET, which turn on server GC by default. Right. Historically, server GC assumed that you own the machine, right? The process that you use server GC in should be the dominant process. But of course, that's not necessarily the case if you run in these like small containers with low memory limits, right? So I did the hard limits feature, and that feature made the memory allocation fairly localized in one place, because we just reserve everything we needed, because you told us like what the limit is, right?
Yeah.
So we reserve the whole thing up front, which means we don't need to do like heap expansion later, which means that would make adding the large page support a lot easier, right? However, there's still some special care you had to take when you're adding the support, right?
Yeah, so after you introduced hard limit, I was really excited to basically start working on getting large page support there, and then voila, you're on Windows, there's things you have to do. You have to make sure you get privileges, even if you're an administrator. So even if your process is running as admin, you still need to acquire the ability to
explicitly.
to acquire the ability to lock physical pages.
Right.
And the interesting thing about the hard limit case was now you had to reserve all the memory, but here Windows also requires, when you have large pages, to commit it.
Right.
So on Windows, basically you acquire these privileges, reserve and commit that entire hard limit number that you specify in your runtime.
That's all going to be in working set up front.
Correct. That's all going to be in working set. On Windows, the definition is slightly different because they can't be paged out. You wouldn't necessarily see it inside the working set number, but you would see it where private bytes increase. So there's a few things that we have to document for that.
Yeah, absolutely. Yeah. Of course, as with perf, often there's caveats, and using large pages is no exception, right? So. Do you want
so basically, the interesting thing about using large pages is that you get an improvement, because now your translations aren't going from virtual to physical. You have basically all these physical pages that are much larger.
Right.
Whereas the OS page size was 4 kilobytes, you can now have a 2 meg large page size, and the interesting conversation that you can have now is, well, okay, so I'm getting these large pages, but does that introduce fragmentation or potential issues with fragmentation? So in fact, we actually go and acquire all the large pages at the beginning of the process, which helps with the problem of fragmentation, which could happen as your program runs.
Because if you have a 2 meg virtual page, you have to have the contiguous physical pages to back that up, right?
Exactly.
If it's fragmented, you may not have a chance anymore later on. Right, yeah. So what happens if you can't acquire all these large pages?
So if you can't acquire all the large pages, basically we throw an out of memory exception and kill the process.
Right.
Now you could...
Right, there's an alternative, which is like, if I can't acquire enough large pages, I could just acquire small, normal pages instead. Right,
that's
but
the first thing.
Against it.
I decided against it, and basically the first thing we thought was, okay, well, maybe we could do that, but then the perf difference between running in large pages versus when you do not get the large pages and are running in smaller pages was significant enough that you as as an application owner would say, hey, my program started fine when my OS just started and was not fragmented, but after running for a while, now my application is suddenly slowed down. And it would be difficult to diagnose as you're running through your application.
Exactly, and that would be a lasting effect, right? So you'd have some kind of unpredictability here and there, so that makes things difficult at best, right? So that sounds great. So, and you told me that you've been seeing like great improvements with large pages. Can you see? Can you show us some numbers today?
Yeah, I actually can show you some numbers.
So we've gone through all these, and there you go.
And so this is basically what you're seeing on your screen is the percentage difference between, so we do a lot of A/B tests and we have to do controlled rollouts of our features. So if you see that yellow graph, that is our one particular region where Bing servers are, where we turned on this feature, basically putting on a hard limit and then saying, enable large pages, gave us an 18% improvement from the baseline.
Awesome.
Which essentially
very significant.
Yeah, which is essentially pretty cool if you think about all you have to do is change one change in runtime config setting. And even though large pages is experimental, which is why we have that on Com+, but you do get that benefit just by changing 2 settings.
Right, yeah, exactly. So this is fantastic. But like there's still more work we can do to make this even better, right? Yeah, there's different page sizes on Windows that you were planning to.
Yeah, so both on Windows and on Linux, there is the ability to change the page size. So as I mentioned, we have 2 MB, but we also have 1 gig. And you can imagine if 2 MB to 4K, so if you have 512 4K pages in 2 MB, multiply that again by the order of magnitude, and you get even less translations.
Right,
so,
exactly.
And it really helps if you're in a VM, when you're running inside a virtualized environment, actually having these larger physical pages being backed by your hypervisor is actually very useful.
Right, and there's also work in GC that we can do, which is, for example, right now, the only thing that we have on large pages is the GC heap itself, right? So, of course, GC has its own bookkeeping data structures, which also take up memory. So we could also experiment putting that on large pages as well. I mean, of course, the memory that GC takes up for itself is a lot smaller, but we may still see some very noticeable improvements there. And as you mentioned that this is an experimental feature, so right now you're still using it by setting the Com+ environment variable. So we were planning to make that available in the runtime config.json, right? So that becomes an officially supported thing.
Exactly.
Right. So that's great. It's really fantastic to see such significant perfect improvements on Bing, which is one of the world's largest workloads.
Yeah, and we're super perf critical, and we always love these kinds of features that essentially make it faster.
Yep. So speaking of startup, I think you're using another feature during startup stage, which is
frozen objects.
Yes, right. So we're gonna wrap up for this part of our walking down the memory lane, but in the next part, we're going to talk about frozen objects.
That's great.
So we'll see you next time.
Bye.